So our objectives today is to get introduced, to rotations and to understand how to perform rotations on a geometric figure. Shh. Ryan, this is getting recorded.
Oh, okay.
And that's really not appropriate. Shh. And then we also want to understand the properties. Shh. Of rotations. And when we talk about properties, we're talking about your beginning shape and your end shape. What do we see that's the same? What do we see that's different? Okay? Ryan, we're taking notes, so you need to take them as well. Shh. We're going to do a little graph. And right now we're just going to focus in on the top part of this graph. So we've got a triangle. And his vertices are at 0, 0, 2, 0, and 2, 4. So we'll have A here at the origin, B will be to the right, and C is going to be the high point. And so what we're going to do is we're going to take this, and we have two directions that we could rotate. We could rotate clockwise, or we could rotate counterclockwise, because what was the one thing every single shape that you guys told me that rotated had in common?
It's been a circle.
Okay, it was a circle.
Oh.
Okay, and so when we're doing clockwise and counterclockwise, a clock is also circular, so that's where the relationship comes from. And so when you're being told to do a rotation, you're going to be told two key pieces of information. You're going to be told which direction you're going to go, clockwise or counterclockwise, which is going to tell you if it's clockwise, you're going to move to the right. If it's counterclockwise, you're going to move to the left. And then they're going to also tell you how much to move by, okay? How much to move by. And so this one says, all right, let's take this triangle. Let's go counterclockwise. What direction is that? Okay.
It's left.
Okay, we're not going to go up, because that would move us off of where we are. Okay, we're going to go left. That's the counterclockwise direction. So let's write that down. Counterclockwise is left, and then clockwise would be right. So we need to understand that set of directions. And then they're going to tell us how much. Now, looking at your axes, what kind of angles are being formed by the x-axis and the y-axis? Right angles. And right angles measure how much?
90 degrees.
Okay. Right angles measure 90 degrees. So when they're asking us to do a rotation, it's only in increments of 90 degrees. Okay? So we're going to be able to go 90 degrees. If I have 90 and 90, how much is that? 180 degrees. If I have one more 90 after that, what would that take me to? 270. And if I go 90 one more time, where am I at?
360.
360. If somebody asks you to do a 360, where do you end up? You end up in the same place. Now, the other thing we have is we need to have a point of rotation. Remember, we've had a line of reflection. Now we're going to have a point of rotation. And they can choose any point. For most of our practices, I think what I'm going to focus in on is if we use the origin as your point. So our shape is at the origin, so that's going to be our point of rotation. So if I asked you to take this particular shape, I wanted to go clockwise. Let me circle up. So I wanted to go, counterclockwise, and I wanted to go 90 degrees, and our point of rotation is the origin. So I'm going to rotate this 90 degrees. What do you think the shape would look like? How would I put those points in onto the graph to reflect, or should I say, not reflect, that's a bad word, to demonstrate I've gone counterclockwise 90 degrees and I rotated around the origin. So it's like I put a pin in at the origin and I took my shape and now I'm going to rotate it 90 degrees. Giovanni, where A's got to stay at A, right? Because he's the point of rotation. Where's B going to end up?
B is going to be at 0, 0, 2.
So this would be our B prime. Okay. Where would our C prime end up being? Where would our C prime? Cameron?
Negative 4, 0.
It would be here. Think about what C is in line with. What is C in line with in the original shape?
Oh, B.
Yeah, so we're going to have to relocate him. The negative 4 is a good idea, but he's got to be in line with the B. Okay?
Negative 4, 2.
Okay? Okay, and so what you see there is a 90-degree rotation using the origin as our point of rotation and counterclockwise, which took us left. And so if you notice, the key place to look for that, did I do a right angle? Is look at this side compared to where he is now. And those two should form a right angle. Okay? These form a right angle, but they're just not attached to each other. So if we're going around the origin, you're going to be looking for a side that's flat. You need to look to where he's 90 degrees. Now we're going to try to do some nice easy shapes as we get ourselves introduced to this. Okay? So again, what you're going to do, if you're going to describe what motion did we just take to get the red triangle, you're going to say that I rotate counterclockwise. Oh man, if I could spell today. Whoa, whoa, whoa. Yeah, that's just bad. Counterclockwise. 90 degrees. Okay? And then we can use the words about the origin. And that's the language that you need to listen to that you're going to hear. It's going to tell you right or left through clockwise or counterclockwise. It's going to tell you how far to rotate it. And then it's going to tell you what is your point of rotation. Okay? So, again, if I go 360, I'll get back where I started. And there's a lot of moves in different sports that do a 360 and you end up where you started. Now if I told you 180, okay, what would happen with a 180?
You would go. Like,
No.
You would.
Knock it off.
I don't really know.
Okay,
You'll go the not the way you were going, will go the opposite way you started from. But like, say if you were looking,
So if you're looking up, you'd be looking down.
yeah.
Okay. So yeah, you're going to be kind of opposite directions. Opposite directions. Okay?
Would it be like a reflection of both axes?
That's a good question. We'll have to explore that one. Okay? We'll explore that one. If I do a rotation 180, is it like a double reflection? So let's use that same simple shape. So if I go 180, or if I go, I'm going to do it bit by bit. I'm going to do the 90 and then I'll do another 90. So if I go, I think I only went 3 on that one. So that would be 90. So now I need to go one more. So let's see if we can get it through a reflection and a reflection. So if we try to go a reflection, let's say from the green guy over the x-axis, we get to here. If we go from the orange guy, reflected over the y-axis, we would get there. So yes, it is like a double reflection, the 180. Okay, good way to think about it. So we can write that as a note. A rotation of 180 degrees is like a double reflection. Cameron, you had your hand up?
Oh, say you make a perfect triangle. Like a triangle, or a triangle. And then you do a 180. Would the 2 points meet up like a line reflection?
Okay, so let's try that one. I'm going to just erase all of this and put back in my axes. So when you're saying perfect triangle, are you talking equilateral where all the sides are the same?
Yeah.
Okay. Now, are we going to put a vertex in the corner? Ooh, this is going
The
to...
point is like, the point is right in the middle of the
Okay,
axis.
so you're saying... Oh, let me think how to do this one. I'm not sure I can draw it exactly the we'll just do something like that.
And then if say you did a 180, would you?
If you did a 180, you would end up... Oops, sorry.
No, you'd be in a different position, but you'd be the same, wouldn't it? No, it wouldn't be off to the side because...
If you it depends on your rotation point. If your rotation point is the origin,
Well, it still would be like that.
because, hold on, the midpoint would be,
Oh, yeah.
like this, and then it would rotate one more time to the 180. So yeah, it would rotate down to the orange. This would be if I did a 90-degree rotation.
Wait, which one's the origin?
The origin is here. Origin's always the origin. The origin is always where the axes meet.
Oh.
So it's not from an vertex, an endpoint, it's from the origin. And I said that's what we're going to focus in on, because we could do other ones, but they get kind of crazy. Okay? All right, so let's clear this guy out, and we'll start a new page. Okay. Y'all need to stop the yawning, because that's not cool for me. Makes me tired. Okay. So now what we're going to do is try a different direction. Shh. So we tried counterclockwise, so let's try something clockwise. So I'm going to go 6s. Please stop pounding.
Oh, I'm sorry.
Will it always be on the 0?
The way we're going to do it, yeah. In real life, no. But we're learning for the first time, so we're going to give you cases that are a little easier to understand. Can we keep the other conversations to non-existent, please? All right, so let's do that similar idea, but instead of putting the base, and so that the origin in the center of a side, let's put a vertex there. So let's take a triangle, ABC. Let's put A at the origin. Let's put B at -2, 3. So I'm going to keep track of these. Oops, go back. So A's at 0, 0. B is going to be at -2, 3. And let's do C at 2, -3. I mean 2, 3, sorry. Okay. And what if I ask you to rotate this? So our directions are going to be rotate clockwise 90 degrees about the origin. Okay, so if I rotate this 90 degrees about the origin, where is B going to end up? So now,
on the line of the x-axis.
so now we've got this. So let's think about this. If we have a rotation of 90, we're at -2, 3.
Yeah, 3, 2.
If we go 3, 2, okay, so we're saying that's where B prime should be. Ooh, that's kind of interesting. And where would C prime end up? So 3, -2? Does that look reasonable? Okay. So, interesting. Look at the ordered pairs.
Oh, they switched.
B, or let's do a different color. B was at -2, 3, but when I rotated 90 degrees, B prime ended at 3, 2. So it's not just the numbers changing position, there was also a sign change. But not for both of them, only for one of them. Okay? Let's look at C. From C, we started at 2, 3. But when we got to C prime, we got to 3, -2. So again, we had a sign change, but it was only one of them that had the sign change. So looking at the original, the Y value stayed the same at 3, or the number did, it switched into the X spot, but then my X values originally became the Y values, but their signs changed. Ooh, that's kind of an interesting one. Where would you predict, if I continued this going 90 degrees, where would the next shape be?
-32.
Well, no, A will be at 0.
So A double prime still is going to stay the same, because that's our point of rotation. So where is B going to end up this time?
3, 2. -3, 2. Oh, no.
What did I 3?
No, 5, no. No, -3 and -2. Oh, -3
No,
and -2.
It's 2, -3.
Okay.
Oh, yeah, huh.
So if we rotate, so here's some things to look at. In our original triangle, B and C were on the same line that were 3 above the origin. B and C in our rotated one, 90 degrees, were in the same line, 3 to the right of the origin. So then when we do the next time, it sounds like we have to maintain that distance of 3 from the origin. So we're going to have a line here. How long is line BC?
4.
4, right? So we're going to go 4 across. Oops. 4 across is going to be my BC, okay? So one of those is the B prime, double prime, and that would be the first one, right? That would be your B double prime. He's at 2, -3. So he was at 3, 2. Now he's 2, -3. C prime would be at what? What is his coordinates?
-2,
-2,
-3.
-3. He was at 3, -2. Okay? So in this one, our y's stayed the same, but now they became the x's, and then we changed the signs. So from A to A double prime, or we'll say ABC, to A double prime, B double prime, C double prime, how much of a rotation did we do clockwise?
180.
Yeah. So we did a 180, or we did clockwise, degree rotation. Okay. All right, what do you think is going to be the next one?
270.
Okay, yeah, it's going to be a 270-degree rotation, but what would be our triple prime values?
A is going to be 0, 0.
We got, that one's easy.
Yeah.
Let's see, what color haven't we used?
And then B is going to be -3, -2. And then C is going to be -3, and
Okay, so B,
you're welcome.
triple prime, is going to be at -3, -2, and C triple primed
It's going to
be at
-3,
-2, +2. So that is a 270-degree rotation. Okay. So we're going to go ahead and practice that on our homework tonight.